Hey, it's Mr. E here, and our aim for this video is how do we differentiate between situations requiring permutations and those requiring combinations. So a permutation is an ordered arrangement of R objects chosen from N objects. The order is important and it matters. So let's look at an example that requires the use of this permutation. You want to get 3 different toppings on your pizza. The available toppings are pepperoni, ham, peppers, mushrooms, and sausage. However, you are a food critic with amazing taste buds, and the order the toppings get placed on the pizza matters to you. How many different ways can a restaurant make pizza for you? Alright, so I just want you to imagine for a second that you're a food critic. So, you're very particular about how the toppings get placed on your pizza. And let me tell you what I mean by that. Pepperoni, ham, peppers. Look, we know that it doesn't really matter the order you put these toppings on the pizza. But for the sake of making this example, imagine for a second that you're a food critic and it matters to you. Pepperoni, ham, peppers doesn't taste the same as peppers, ham, pepperoni. The order is important to you because you're a food critic. And so just imagine for a second. Since the order is important to you because you're a food critic and the order the toppings get placed on the pizza matters to you, we're going to be using a permutation because a permutation is an ordered arrangement of R objects. Okay, so how do we calculate the different arrangements for this food critic here who's very particular about how the toppings get placed on the pizza? Well, there's a total of 5 toppings, so that's your N, and you want to just pick 3 out of those 5, so R is 3. So we're going to write 5P3. Now, if I'm going to be using the formula, that would be equal to 5 factorial over 5 minus 3 factorial, which would be 5 factorial over 2 factorial. But I'm not going to do it that way. I'm going to show you how to do it on the graphing calculator. So what you're going to do is you're going to press 5 first. Then you're going to go to math. You're going to go to probability. And you're going to press number 2 or pick NPR. And then you're going to write 3. So 5 NPR 3. And there's 60 ways that they can make pizza for this food critic. 60 ways. Okay, so that's a permutation. In a permutation, the order matters. It's important. What are some examples of these combinations? Well, pepperoni, ham, peppers. We said already peppers, ham, pepperoni. You can also have peppers, mushroom, sausage, sausage, mushrooms, peppers, and so on and so forth. There would be 60 of these combinations that if we were to list them all out, we would go over our 10-minute time limit for our video. But those are just some examples. Okay, what's a combination? A combination is an arrangement of R objects chosen from N objects, and the order of the selection is not important. So that's the main difference. In a combination, the order is not important. So let's look at an example where we would use a combination. You want to get 3 different toppings on your pizza. The available toppings are pepperoni, ham, peppers, mushroom, sausage. But this time you are a regular Joe and the order of the toppings does not matter to you, how many ways can you have a 3-topping pizza? So since the order doesn't matter, we're going to be using a combination. So again, our total is going to be 5. And since we're picking 3 out of those 5, our R is 3. So it's going to be 5C3 this time. So what is that? Let's type that in our calculator. 5, go to math, probability. This time you're going to press number 3 or scroll down to NCR. And then press 3. So you get 5 NCR3, hit enter, and there are 10 available pizzas when the order does not matter. Now, let's think about why that is. Why were there more arrangements when you were a food critic than when you were a regular Joe? Let's think about that. Well, since the order mattered in this example, pepperoni, ham, peppers is not the same as peppers, ham, pepperoni. You're counting that as 2 different arrangements. And it'll be the same with all the other ones. So you're obviously going to get more arrangements here in the first example when you're a food critic. If you go to the second example, the order doesn't matter. So pepperoni, ham, peppers is the same as peppers, ham, pepperoni. So obviously there's going to be less options this way because the order does not matter to you. Okay, so why were there more arrangements when you were a food critic than when you were a regular Joe? Well, because when you were a food critic, the order was important. When you were a regular Joe, the order was not important. So to summarize, a permutation, the order is important. It matters. In a combination, the order of the selection is not important. So to answer our aim, how do you differentiate between situations requiring permutations and those requiring combinations? Well, you got to ask yourself, is the order important? Is the order not important? If the order is important, then it's a permutation. If the order is not important, it's a combination. It says, determine whether the following situations would require calculating a permutation or a combination. Take a minute to think about it. Okay, I hope you thought about it. So for the first one, it says selecting 3 students to attend a conference in Washington, D.C. So let's just say these are the students you have to choose from. Jurgen, Samaj, Daler, Justin, Olufemi, Sanjay, Denzel, Serafina, and Calvin. Okay, does it matter how I pick my 3 students? Say, for example, I'm going to pick Jurgen, Samaj, and Daler to go to DC to this conference. Does it matter if I say, Jurgen, Samaj, Daler, you're coming with me to DC? Or what if I say, Daler, Samaj, Jurgen, you're coming with me to DC? Or what if I say, Samaj, Daler, Jurgen, you're coming with me to DC? Does it matter the order that I say it in? No, it doesn't matter. So it's a permutation. Selecting a lead and an understudy for a school play. Does the order matter? Does it matter who is the lead and who is the understudy for this school play? Yeah, it does. It does make a difference because if you're the lead, you have to be the first pick. If you're the understudy, then you're the second pick. So the order matters. It's a combination. Assigning students to their seats on the first day of school. Does the order matter? Does it matter the order I place them in their seats? Yes, it does. So it's a permutation. Say, for example, if you're still not sure about letter C, right? Say I got my seats. Let's just say these are seats. I know that this is a very bad drawing. Doesn't matter how I'm going to assign the students. What if I decide that Jurgen sits here, Samaj sits here, Daler sits here, and Justin sits here. Is that the same as saying Samaj, Jurgen, Daler, Justin? No, it's not the same. The order matters. That's why it's a permutation. Example 3. 5 people have volunteered to work on an awards dinner at Madison High School. How many different committees of 4 can be formed from the 5 people? Think about it for a second. Does the order matter? Does it matter? Think about it. Okay, so let's just imagine for a second that the 5 people that volunteered are Olufemi, Sanjay, Denzel, Sarafina, and Calvin. If I'm going to form my committee with 4 people from here, does it matter if I say that my committee is Olufemi, Sanjay, Denzel, and Sarafina? Doesn't matter the order that I put them in. Well, I think 1, 2, 3, 4. Yep, I got 4 there. Doesn't matter what order I put them in. No, it doesn't matter because you're in the committee regardless. So this is going to be a combination. So it says how many different committees of 4. So that means my R is 4 and my N is 5. There's a total of 5 people. So it's going to be 5C4. And that's equal to 20. Okay, you try it. Look at the questions below, determine which is most appropriate to use, permutation or combination, and then answer the questions. Hope this video helps.